Welcome to Q&A Wire.
So in this problem, we have to estimate the probability of finding an electron in the ground state of hydrogen atom within the nucleus, uh, which is a sphere of radius 1.1 femtometer. So basically, we have to calculate the probability of finding the electron from r equals to 0 to 1.1 femtometers. And we use the equation and P of R dr. Now the probability distribution is given by probability distribution is given by equation 39(7), which is 4 r square over r naught square, sorry, r naught cube e to the power minus 2r over r naught. Now, as we already know, the Bohr's radius is 0.529 times 10 to the power minus 10 meters, and the size of the nucleus is given as 1.1 times 10 to the power minus 15, sorry, 10 to the power minus 15 meters. So as you can see, R naught is much greater than R. In this case, R naught is 52900 femtometers, whereas R is just 1.1 femtometers. So in this case, we can say that, let's move on to the next page. So when R naught is much greater than R, we can approximate the quantity e to the power 2r over r naught as approximately equals to 1, because the ratio 2r over r naught is much smaller than 1, and which implies that basically this quantity, which is much smaller than 1, let's say it's basically goes to not to 0, much smaller than 1, that quantity equals to 1. So basically this thing. So what we do is to calculate the probability of finding the electron from 0 to 1.1 femtometer. We just use this equation. So we have, for e to the power minus r over r naught, we have substituted 1. So we take out 4 over r naught cube constants outside of the integration, 1.1 femtometer r square dr, which basically integrates to r cube over 3 from 0 to 1.1 femtometer, and we have 4 by 3, 1.1 times 10 to the power minus 15 whole cube over 0.529 times 10 to the power minus 10, sorry, 10 to the power minus 10 whole cube. So this basically comes out to 1.2 times 10 to the power minus 14. Okay, so this is the probability of finding the electron within the nucleus, okay, which is very small. It's of the order of 10 to the power minus 14. Now let's move on to the problem, part B of the problem, in which case we have to calculate the probability of finding the muon, which is the same as electron. It has the same charge, but the mass of muon, let's say mm, is 200 and okay is 207 times mass of electron. Let's say mass of electron is me and mass of muon is mm. Okay, in this, so for this part we use the information from chapter 37 equation 11 from section Bohr's model, which basically tells us that the radius is inversely proportional to the mass of the particle. So let's say if we use Bohr's radius for electron, the mass is inversely proportional to the mass of the electron. If we had calculated the Bohr's radius for muon, so r0 is Bohr's radius, m is for muon, then it will be inversely proportional to the mass of muon. So if we take a ratio of both of these quantities, so we have Bohr's radius for electron over Bohr's radius of muon, which basically gives us Bohr's radius of mass of muon over mass of electron. So R0e over R0m. So mm is just 207 times me over me. We have me cancels, and then we basically see that Bohr's radius of muon is just Bohr's radius of for electron over 207. So this means that if we replace the electron by a muon, then in the probability uh, in the probability equation that we had, which was 0 to 1.1 femtometer for r square over r naught cube, e to the power minus 2r over r naught dr. This quantity is for muon. Okay, so we just replace this by, and this quantity is already shown in part A to be approximately equal to 1. So we basically use 4 times r square over r naught m square dr. So we have 4 over r naught m square r, no, sorry, this is not r, this is cube, sorry, this is cube over 3, 0 to 1.1 centimeters. Now this r naught m is r naught e over 207, and we already know what is the value of r naught e. r naught e r naught e is 0.529 times 10 to the power minus 10 meters. So we substitute that value in that equation. So what we basically get is 4 over 3, 1.1 times 10 to the power minus 15 cube over, sorry, over 0.529 times 10 to the power minus 10 over 207 whole cube. So we basically get, after solving this equation, we have the answer as 1.1 times 10 to the power minus 7. So as you can see, the probability of finding a muon is much greater than probability of finding the electron, because muon is heavier than electron. Thank you.